Hello, my name is Andrew Richards. I'm the founder and CEO of Codeplay. We're a programming models company that does things for high performance computing, originally graphics processors and video games and things, but now the world's fastest supercomputers and autonomous vehicles. And we're based in Edinburgh, in Scotland. So the vision for the company is to enable people to unleash their software from CPUs, then onto GPUs, and then onto future XPUs. So whatever kind of processing unit you might design for the future. And as you move that software from the CPU onto these more efficient processors, you enable much higher performance and efficiency. And of course, there's all sorts of use cases for this, whether it's supercomputing or autonomous vehicles, but today we're going to talk about high performance computing. So an example that we can talk about is in the US, there are multiple supercomputers based on different architectures. So they've chosen two exascale systems, one based on Intel GPUs, one based on AMD GPUs, and a pre-exascale system based on NVIDIA GPUs. So the key challenge is, how do we write the software so it will run across all of those systems and deliver maximum performance? And it's huge amounts of software. So the DOE talks about 10 million lines of code that needs to be able to run across these systems. So some established systems like directive-based programming for Fortran and OpenMP are quite established, but it's difficult to scale them to some of the really high modern heterogeneous architectures, high performance workloads. And so today a lot of people use C++ techniques. And what we've done at Codeplay is we led the definition of the SYCL industry standard. And then Intel has adopted the SYCL industry standard as part of their one API, and then they've created a larger ecosystem around that. And what we do is we support the supercomputer vendors and Intel in enabling that software to run across all of those different systems by implementing compilers, some of them open source, some of them closed source. And there's a huge range of software that's now being supported on the SYCL industry standard. So people ask us about performance, of course. So one really good case study is from the Zuse Institute, Berlin. You can see them talk about their case study. What they had is they had some CUDA code that did a tsunami simulation. And what they did is they used Intel's compatibility tool, which you can download for free from Intel's website, that will convert the CUDA code into SYCL, or Intel's extensions of SYCL, called DPC++. And then once you're in that format, you can then compile it and run it on a bunch of different architectures. So if you use Codeplay's version of this compiler, which is open source and runs on top of NVIDIA GPUs, then you actually get 96% and above performance pretty much out of the box, still on the same NVIDIA GPUs, but now your software is unleashed and you can run it on a variety of systems, whether it's Intel GPUs or Intel CPUs, even Intel FPGAs. And in the future, any SYCL supported processors. So we support a bunch of different processors as well, by things like RISC-V and OpenCL to be able to run on a bunch of different systems, and other people can implement the industry standard as well to be able to support on new processors. So it's a very small reduction in performance that you're sacrificing for a very small amount of effort to get huge amounts of flexibility in terms of your ability to spread your software. Now, what Codeplay actually provide is a platform called Akaran, and we integrate a bunch of different technologies in that. So one of the things that we support is basically the open source one API based product, where we support a whole suite of software, including the SYCL industry standard, on today NVIDIA GPUs, and then we're working with the national labs to also be able to support that on AMD GPUs as well. And of course, Intel supports exactly the same open source software on Intel GPUs and FPGAs as well. And then for some of our customers, they're actually designing chips that are going to compete with GPUs. And so we have a compute CPP product and a compute auto product that helps them actually do that. So we call it differentiated compute. It allows you to build a processor optimized for different kinds of workloads, and we can provide that all of the software stack to make something look like a GPU, even if it's actually a very different, much more power efficient processor. And for people who want to be able to design their own processors, we actually provide further technology that allows you to take existing workloads and actually run them on different processor designs in simulators. So you can design your own processor and you can evaluate these real-world high-performance or AI workloads on lots of different processor designs. And we base a lot of that on RISC-V, but you can plug in your own processor designs as well. So how can you take part in this revolution? You can port your software to SYCL and OneAPI today. So you get the performance of a proprietary GPU programming model. You get all the parallelism and offloading and everything, and you get the full feature set of C++, but without being locked into one vendor. So you can then move your source code across lots of different processors, both now and in the future. And all of that software you can have available today, open source. What you can also do is you can design your own chip around real-world software. And you can design a very customized chip, optimized for real-world AI and HPC software. So you can start with large-scale real-world software that your customers may have. But SYCL actually gives you a lot of hardware flexibility. So you're not restricted by a lot of things you might need to do for CPUs, like cache coherency. You don't even need to have caches at all. You can have lots of different memory spaces and DMA systems. There's all sorts of stuff that you can do and still run SYCL, because we've designed SYCL around that. And not only that, SYCL has an auto-tuning capability that allows you to auto-tune the software for your new processor architecture. And if there's things that you want to improve about the SYCL or OneAPI standards, both of these groups are groups that you can join and you can participate in. So you can actually drive the progress of these industry standards for programming models in the future. So maybe if you've designed your own hardware architecture and SYCL does things that are a little bit different on your architecture, you can actually join the SYCL group. And if you find that SYCL doesn't have the software features that you need for the software that's very important, you can also join the SYCL group and you can ask for those features to be included in new versions of the standard. And the SYCL standard is being very rapidly developed and improved. It's a very lively group. There's a lot of activity going on because there's lots of people developing exascale software and other kinds of software, autonomous vehicles, all sorts of stuff based around the SYCL standard. And that's it. We would love to have you participate in these, and we would love you to contact Codeplay if there's things you'd like us to help you with, and we have a bunch of stuff on our website that you can download for free and evaluate if that's what you're interested in. Thank you very much for your time.